Today we started classifying, naming three-dimensional solids, and we also learned Euler's polyhedron formula for the relationship between the faces, edges, and vertices of polyhedrons. This is a polyhedron, this block. It has two parallel and congruent triangular faces, which we call the bases. They're parallel to each other and they're congruent, so it's a prism. And then the prism is named by the shape of the base, which is a triangle. It's actually a right isosceles triangle, so I could be even more specific, but we can call this a triangular prism since it has two bases which are parallel and congruent. If it were a pyramid, it would have a single base, and then all the other faces would be triangles going to a single vertex. You're familiar with what a pyramid looks like. So the question is, number 7, is it a prism or is it a pyramid? At first glance, it might look like neither, because if you think about this face, it might be a square or a rectangle, it's hard to say. But this base, this face is clearly not parallel to this top face. They would eventually intersect out here somewhere. So these bases are not parallel, nor are they congruent. Neither are the right and left faces. However, the front face, this trapezoid, is congruent to this back face, this other trapezoid. And if you think about taking that trapezoid and standing that polyhedron up on the trapezoid, you can see that those trapezoids are parallel to each other. So we do have a prism here, and I'll outline the faces which are the bases of this prism. Here's a trapezoidal face. The other one is back here. And since these trapezoids are parallel and congruent, then we have a prism. So it's a trapezoidal prism. We have how many faces? We have to count. Let's see, the two bases are also faces. So we have 2, and then we have 1, 2, 3, 4 other faces connecting the two bases. Because the base is a quadrilateral, we have the 2 bases which are faces. So 2 plus 4 more would be 6 faces altogether. As far as edges, we have 8 that we've identified so far when I outlined the bases. Since both trapezoids are quadrilaterals, we have 8, and then we have 4 more edges connecting these vertices. So we have 8 plus 4, or 12 edges altogether. As far as vertices, we have vertices are where the edges intersect. So we have 1, 2, 3, 4 vertices here. And then 1, 2, 3, 4 more back here, for a total of 8 vertices altogether. And that's a lot of counting, so it's nice to have a formula to check. And we have Euler's polyhedron formula, so I'm going to rewrite it. You're checking your count for each problem by substituting into this formula. So the faces are 6, so 6 minus the number of edges are 12, 6 minus 12 plus the number of vertices 8 should equal 2 if we did it right. 6 minus 12 is negative 6, and negative 6 plus positive 8 is positive 2, so 2 equals 2, and that checks out. The other problem I'd like to look at is problem number 20. Problems 13 to 20 ask you to identify the three-dimensional figure that is formed by each net. So this is a net. It's I'll use this as an example again, this triangular prism. If I were to unfold its faces, I would have these 2 right isosceles triangles, and then 1, 2, 3 rectangular faces, all connected in this 2-dimensional net that could then be folded to create the polyhedron. We have something similar here. We have 2 5-sided polygons. Five-sided looks like regular polygons. A five-sided polygon is a pentagon. And then we have these 1, 2, 3, 4, 5 rectangular faces. In order to answer this question, in order to name this figure, you have to sort of be able to, in your mind, fold up. This is not easily done, but the more practice you get, the better you are at it. Imagine if you folded up these rectangular faces and tried to create a polyhedron from this net. What polyhedron would you have? Would you have a prism? Would you have a pyramid? If you have a pyramid, what's the shape of the base? If you have a prism, what's the shape of the base is? And then name it accordingly. So try to do that during the pause and come back and see how you did.
Paused.
If I folded up all three of these rectangular faces, and then I folded this pentagon over, I see that these pentagons would be right above one another. They'd be parallel, and they're clearly congruent. These other two rectangular faces could be folded down to close in the figure. So since I have parallel and congruent faces, we know this is a prism. A prism has two bases. A pyramid only has one base. So we know this is a prism. And then the name of the prism is based on the shape of the base. The base is a pentagon, so this is a pentagonal prism. Okay, I hope that helped with the homework.